prominent physicist, Dr. Richard Feynman, at the annual American Physical Society meeting in 1959, made a famous statement: "There is plenty of room at the bottom." Meaning, even in the most minuscule world, manipulating and controlling small objects is still possible. Because when objects are shrunk, there is still space for development. This is the first time scientists imaginarily outlined the nanometer scale world. While the term nano has become better known in the past few years, it is not something totally new. It is just a unit of length that is even smaller than centimeters and millimeters. If the diameter of the Earth were 1 meter, then a nanometer would be the diameter of a marble. When people can view the world at a nano scale, seeing is no longer enough to believe. In the minuscule world that the naked eye cannot see, the commonly known theories and knowledge are no longer useful. We start from zero to explore the amazing mysteries at the nanoscale. Water drops on the lotus leaf are sparkling clear and round like pearls. Normally, as water drops on the surface of an object, it either spreads or is absorbed. How is the lotus leaf capable of totally warding off the water drop? Because on the surface of the lotus leaf, there is a layer of less than 10 nanometers, an uneven cuticle layer, covered with organized nanostructures to lessen the contact of the leaf's surface and water drop, causing the water drop to only roll on the surface, and forming the most perfect water drop effect. The high skill of geckos climbing on walls belies yet another nano kung fu. This kung fu is not a suction cup, but rather super thin nano fiber. This is the secret behind the gecko's kung fu. Its feet have hundreds of millions of fibers, and the tip of every fiber has hundreds of ultra-small structures called spatulas that can tightly stick to any surface. Geckos rely on these spatula to move freely back and forth on ceilings. Whether it is the freshness of lotuses growing out of mud, or the wall-climbing skills of the gecko, mankind has moved from awe and admiration to observation, decoding the nanoscale phenomenon, and developing nanotechnology in the natural learning process. October 2001, the Taiwan Nano Exhibition at the Taiwan World Trade Center. And the most bustling spot in the exhibition is a booth teaching about nano, which is constantly surrounded by children big and small, playing with the nano phenomenon experiment. Just like kids filled with curiosity, scientists are also fascinated by the various phenomena of the nano world. To catch up with cutting-edge research, the National Science Council Taiwan, in 2003, started the National Science and Technology Program for Nanoscience and Nanotechnology, combining the resources of industry, government, academia, and research. The National Nanoscience and Nanotechnology Program Office was set up at the Institute of Physics and Academia Systems. It is responsible for initiating many research projects, including that of Dr. Jia Sheng Zhang, a research fellow with
全部都变形，
Physics,
像这个其实很明显
and a member of its research group, a surface and nanoscience laboratory.
表面科学基本上呢，严格说来是研究一个物质的内部跟外在环境的一个边界，所以那在这个边界上面一定有很多事情发生啊。那问题是我们平常直观的时候，你不觉得有什么发生，但是你把它放到原子的尺度来看的时候，其实发生很多事情。比如说一个桌面，对不对？你看起来平平的，没有什么感觉，但科学家在看的时候，尤其放在原子尺度下来看的时候呢，它其实有非常非常丰富的一些现象。
These wonders that can't be seen with the naked eye have made scientists fascinated with the nano world. Others who are fully committed to this field of research are the scientists of this research lab. The Institute of Atomic and Molecular Science at Academia Sinica, established in 1995 through the efforts of many academicians to further research exchanges between universities. This institute was set up outside the Academia Sinica campus at National Taiwan University.
"到了最近几年来，已经就是20-30年有成。其实我们特别在分子反应动力学上面这个领域里面，我可以很持平的说呢，事实上我们在这个领域是在全世界上是遥遥领先的。
The field that Yuling Wang's team focuses on is advanced materials and surface science. He believes that his scientists, besides doing pure research, can within their lifetimes develop some applications from their research results. Perhaps they can more quickly contribute to society and mankind.
所以我们在10多年前，就是我回来的时候，我们开始成立了表面科学跟尖端纳米材料这个研究。那这种研究呢，就比较有科技的性质。它的目标就是说，希望在至少在我们有生之年呢，能够真正的对人类的社会有一定的贡献。
One is the newly established Original Branch Institute set on the campus of National Taiwan University. One is the Institute of Physics established within Academia Sinica. Both are doing nanoscale research, both under the same Academia Sinica framework, with Jiasheng Zhang at the Institute of Physics and Yulin Wang at the Original Branch. The research focus of the two teams is very different. At Academia Sinica's Institute of Physics, the team led by Jiasheng Zhang primarily researches the basic material of semiconductors, silicon, examining at the atomic scale the surface and interface characteristics when silicon is combined with other materials. Additionally, Yuling Wang of the Original Branch, Jinkai Wang of the National Taiwan University Center for Condensed Matter, and Lin Ji-hong of Yangling College of Microbiology and Immunology organized a cross-disciplinary physics and biomedicine research team. Taking nanoscience to the next step of nanotechnology and improving current clinical bacterial detection technology, the nanotechnology developed by human beings is very backward in comparison to the long extant nano world of nature. But we are quickening our steps, catching up, probing the unknown, and exploring infinite possibilities in the world at the minutest scale.